Hi, it's Paul. Welcome to the channel. Today we're going to have a look at integration by substitution. Come on. I've chosen cos x over sin x. Now, you could integrate this other ways. You could do reverse chain rule, comes to mind actually, or perhaps parts or some other trick, but that's the beauty of integration. You can sometimes use more than one method. I'm giving you a substitution. U equals sin x. You may or may not be given that. You may or may not be told it's a substitution question. The first thing I do, differentiate the substitution. Sin x goes to cos x. The next thing I do, rearrange that to make it dx equals. And I usually put a little circle around that because it's almost like side working. And by the way, a little bit controversial. I always kind of got told that when I was a young lad that multiplying that dx up was a little bit controversial. I think it's maybe a little bit less controversial in the modern day, but let me know in the comments how you feel about that. Splitting the du and the dx. But that's what you got to do and make it dx equals, because now I have a dx equals, which I can pop there, and I have a sin x equals, which I can put there. The goal is to change all the x's into u's. Let's see if we can do it. Cos x, we don't have anything for that. We've got du by dx. I'm not going to put that part of it in, okay? So I'm just going to keep the cos x, see what happens. Sin x, that is u from the substitution. And dx is du over cos x. Notice, cos x is cancel. And you're left integrating, if you like, 1 over u du, and the integral of 1 over u is ln u. Plus c. Finally, put the u back in. Now, that's not ln times sin x. That's not ln add sin x or something else. It's ln of sin x. The sin x goes inside the function of ln. And you got your answer. Turbo recap. I've given you the integral. I may or may not tell you it's substitution. I may or may not give you the substitution. Here I told you it's u sin x. First thing, differentiate that. Goes to cos x. Second thing, rearrange it so it's dx equals. Third thing, put that in to change the x's to u's. So once you do that, in this case you notice the causes cancel and you're left with 1 over u du. Integrate that as ln u and sub back in your substitution so you've got it in terms of x to finish. I should say, there's no guarantee from the skies that your substitution will work. It's a trick. It may or may not work. I knew this one would work. But because the cos x is cancelled nicely, but it might not work. The overall policy, the overall vibe, the sort of feeling of it is you're allowed to make any substitution for the integral that you like. Okay, you can choose anything. U equals e to the 12x squared minus 9 squared, whatever. You can make any substitution you like, but you pay a price. And the price you pay is, you must also change your dx to du. So anything you want, you can sub it in. I could have subbed in cos x over sin x, but I'm then forced to change my dx. I would have a harder derivative to do here, and it might not simplify the integral. So that's the policy. Any substitution you like, but you pay the price. And in this case, a carefully chosen substitution can get you the answer you need. Sin x works lovely here. You could also use potentially cos x here. It might also work. That's something for you to try as an exercise. And it can get interesting with the substitutions as we go along. But for now, that's a little introduction to integration by substitution.